Let's see the general method for solving degree 2 linear homogeneous recurrences. So suppose we have a recurrence of the form an equal to c1 an minus 1 plus c2 an minus 2. And so this is a degree 2 because the value of an depends on the previous two terms. And our goal is to find the closed formula for an. So instead of computing the sequence one term at a time. Now, the key idea is going to be to look for solutions that behave like exponentials. So we're essentially going to assume that we have solutions of the form an equal to r to the power of n. Now, this may seem like a guess, and it actually is a guess, but it's a good guess. And the reason for that is that exponential sequences interact quite nicely with recurrences. So if an is equal to r to the power of n, if you replace it in the equation, right, then an minus 1, so then an minus 1 will be r to the n minus 1, and an minus 2 will be r to the n minus 2. And if you replace that into the equation, you get this r to the power of n equal to c1 r to the n minus 1 plus c2 r to the n minus 2. And now if we divide by r to the n minus 2, we get that we get this equation here, that r squared minus c1r minus c2 is equal to 0, right? So this equation is called the characteristic equation. And so what this means is if we have solutions of the form r to the power of n, they are going to be found by solving, like the r will be found by solving this quadratic equation. And so now we solve this quadratic equation, and suppose that it has roots r1 and r2. Then there are two main cases, right? Or just two cases actually. So first, if the roots are distinct, so you have two cases. Either the roots r1 and r2 are distinct, or they are the same. Well, in the case where they are distinct, the general solution to this is going to be of the form an equal to alpha r1n plus beta r2n. And if the roots are the same, so you have what's called repeated roots, so r1 equal to r2 equal to r, then an is going to be of the form alpha plus beta n r to the power of n. And now these alpha and betas, you find them by using the initial conditions. So you have the initial conditions to the problem, and then you replace and you solve a linear system, and you'll be able to find alpha and beta.